Good morning. I'm Swaroopa, working as an assistant professor in Marri Laxman Reddy Institute of Technology in Management. Today, I'm going to tell about the first order logic. That is, short form, we can say it as a FOL. The first order logic, it is another way of we can represent the first order logic in another way as a knowledge representation in the artificial intelligence. See, this is another way for the representation of the first order logic. There is nothing but the knowledge representation. So it is the extension of the preposition logic. And FOL, this is also known as the predicate logic. We can also say it as it is also as a predicate logic or a first order predicate logic. Okay, basically it is another way of the knowledge representation, and it is also known as a predicate logic or a first order predicate logic. And the next one in this FOL, the first order logic, it consisting of a mainly three parts. Three things we include. First one is objects, relations, functions. See, in the FOL, we can assume the following things. For the objects are nothing but in the general we can say it as a B, or else the people, or else some numbers, or else some colors we can recognize as it as a objects. And the relation is nothing but there are the relationship between the two objects, like commonly generally we can say the relationship between the two sisters, the relationship between the two brothers we can represent as a sister of, and we can represent as a brother of. Okay, we can represent in the brother of, or else between, comes between. Okay, these are the relationship that we include in the objects. Suppose if we consider two objects A and B, assume the relationship between the relationship between the two people is nothing but it may be a sister of, it may be a brother of, or it be between two of them. This is the relation how we are classify. Whatever the relations that we are using, the same functions that we are using in the functions also. Okay, the relations what we are using, the relations that we are including in the functions also in the FOL. And the next one is this is nothing but the syntax. Okay, the syntax of the FOL. Mainly the syntax of the first order logic, it includes the syntactic elements and the logics and the symbols. See, okay, in the first order logic there will be some symbols will be there. Some with that symbols there will be with that symbols we are going to form some expression. Okay, there will be a certain symbols. With these symbols we are joining these symbols by some expressions we are getting, some logical expressions we are going to calculate in the first order or logic. Okay, the syntactic element in the first order logic, it consisting of a symbol. With these symbols we are including in this logical expressions. According to this, the logical expressions we are going to calculate in this particular symbols. Okay, is nothing but the syntax of the first order logic. Next, this FOL assume this following things. These are the three things in the FOL. What are the three things means? First one is its objects, and the next one is its relations, and the next one is its functions. Okay, these are the three things that we follow in the first order logic. Objects is nothing but basically previously I have discussed, these are the A, B, people. These are nothing but the objects. And the next one is relations. The relation is nothing but the sister of, the brother of, and has color, comes between, which comes under the relation. And the next one is function. What do you mean by function? Father of, best friend, third inning, end of, all this it includes the function. These are the three things that we assume in the FOL. Okay, the next one is the basic elements of the first order logic. Okay, these are the basic elements of the first order logic. Those are the constants, variables, predicate, functions, connectivities, equality, and quantifier. Okay, when we are using in the first order logic, these are the basic elements that we are going to identify in the FOL syntax. Whatever we are writing the syntax, this we will use. First one is constants. Constants that we the numbers, some names, like that we can consider as a constant. And the next one is variables. The variables that we are using for the particular name, that those are nothing but the variables. And the next one is predicate. Predicate is nothing but it's all about the relationship between the two objects or two variables. And the next one is function. Function is nothing but square root function, left leg of function or right leg of function. These are the functions that we are using. Next one is connectivity. So these are the symbols: and symbol, or, implies, negation, by implies. These are the connectivities that we used in the first FOL syntax. And the next one is equality. Here this symbol is nothing but the equality symbol, and this is the quantifier. These are the two quantifiers that we are using in the FOL, first order logic, that is universal quantifier and extension quantifier. Okay, these are the elements that we are using in the first order logic. Okay, and the next one is extensions and the notational variations. See what do you mean by this extension and the notation variations? In the extension and the notation variation, first one is atomic sentences. In this atomic sentences, they are formed by the some predicates. Okay, there will be some predicate symbols that we are using. With this predicate symbol was combined, and we are getting into this parenthesis. Whatever the symbols are there, that symbols that we are keeping in this as an atomic sentence. For example, Ravi and Ajay are brothers. Okay, brothers. So brothers, that is Ravi comma Ajay. Chinky is a cat of Chinky. Okay, this is the example that we used for the atomic sentences. Just the relation that we mentioned before in between the names that we include in this parenthesis. And the next one, Chinky is a cat, is nothing but cat will be there. In that we are using here Chinky. Okay, Chinky is nothing but we are mentioning here. And the next one is complex sentences. Complex sentences are made by combining atomic sentences used connectivities. Complex sentences is nothing but just in the complex sentences we are using the atomic sentences. Okay, there is nothing but the complex sentences. Again, this first order logic as in the complex sentences, this FOL is divided into two parts. Okay, first one is subject and the next one is predicate. Subject is nothing but it is a main part of the statement, whereas the predicate is nothing but it's a relation between the two atoms or together. Suppose if we take any two objects or any two atoms, the relationship between them is nothing but the predicate. Okay, this FOL is divided into two types. First one is subject and the predicate. Subject is nothing but it's a main part, and predicate is nothing but it's a relationship between the two objects. Next one is the quantifiers and the first order logic. See, there are the two types of the quantifiers in the first order logic. First of all, what do you mean by quantifier? Quantifier is a language element which generates the quantification. Okay, it's a type of a language element which generates the quantification. See, in this quantification, there are the certain symbols to determine identify the range and the scope of the variables in the logical expression. Okay, these are the symbols that we permit in the range and the scope. Okay, quantifier is nothing but a language element. To that language element, we are using some symbols to determine some logical expressions. Again, these quantifiers are divided into two types. First one is universal quantifier and the next one is extensional quantifier. Okay, what is the difference between the universal quantifier and extensional quantifier? This universal quantifier is defined with a symbol that is a reverse of A. An extensional quantifier is represented with the reverse of E. These are the two symbols that we represent for the universal and extensional quantifier. And the universal quantifier is nothing but for all, for everyone, okay, and everything. Extensional is nothing but only for some persons. A universal quantifier is a symbol of logical representation which specifies the statements within range of true of everything. Okay, this universal quantifier is represented with the invert of a. See, in the universal quantifier, these are the three variables that we include the universal quantifier: for all x, for each x, for every x. And then let's see, this is the one example for the universal quantifier. By seeing this example, we will get some idea about how the universal quantifier is going to work in the FOL. See this example, all man drink coffee. See how we are going to write this particular statement in the form of a this universal quantifier. How we are going to notate the shorthand notation, how we are going to represent in this universal quantifier. See, suppose x1 drinks coffee. Assume x1 drinks coffee, okay, and the x2 drinks also coffee, and x3 drinks milk, up to so on xn drinks milk. This how we are going to represent in the shorthand notation is nothing but for all x, man of x, that implies drink x comma coffee. Okay, see, this universal quantifier is nothing but it goes under for all, for every, for each and every person it includes. That we are mentioning here as a inverted A. Okay, that is x of man x that drinks coffee x comma coffee. We can represent like this in the universal quantifier. And the next one is extensional quantifier. What do you mean by extensional quantifier? Extensional quantifier, it was the type of a quantifier which expresses statements. It is, see, in the extensional quantifier, it denotes only for one person only. Okay, and it is denoted with the logical operator, that is reverse of E. Okay, see, in the extensional quantifier, it includes only at least one instance of something, whereas universal, which indicates the for all, for every, okay, for all, for every, and for each and every person, it includes in the universal quantifier, whereas extensional quantifier, it includes only the one instance of something. Okay, this is how we are going to represent for the extensional quantifier, whereas the universal, it includes 3, extensional also it includes 3. In the extensional quantifier, there exists x for some, there exists x for some x, for at least one x. Okay, that extensional is nothing but it only one. Okay, whereas universal, it includes for all. Okay, and the next example is some boys are intelligent. Okay, how we are going to represent here? X1 is intelligent, or X2 is intelligent, or X3 is intelligent, or Xn is intelligent. So shorthand notation, we can write extension of X, boys of X, and intelligent of X. Okay, this is how we are going to represent for the extension quantifier. Okay, see here the symbol that we represented with the reverse of E. Okay, for all these statements, we can represent in a single shorthand notation like extension of X, boys of X, and intelligent of X. This we can represent. This is the purpose of the universal and the extension. Whereas the universal, it consisting of so many statements, we can represent in only one statement. Whereas the extensional quantifier also, it can be so many statements, we can represent it with the only one statement. Okay, next one is knowledge engineering process. Knowledge engineering in the artificial intelligence is a process. It's a process of capturing, modeling, and representing and integrating knowledge in the computer system. Okay, knowledge is nothing but capturing, modeling, representing, and integrating knowledge into computer system. This knowledge can be represented in the form of how the computer can understand. Okay, the purpose of knowledge engineering in artificial intelligence is to software that makes judgments similar to the human specialist. Okay, the judgments are similar to this human specialist. The knowledge engineering help the transformation human knowledge into machine readable. This is one of the feature for the knowledge engineering, the human knowledge into machine readable format. Okay, this is it can be by comparison performing the intelligence. These are the two features that we involved in the knowledge engineering. And the next one is knowledge engineering process. This is a knowledge engineering process, how we are a step-by-step process that we include. The first one is a task identification, and the next one is acquisition of a knowledge, and third one is preparation of the roadmap, and fourth one is encoding, and the fifth one is evaluation and the debugging, and the sixth one is the justification and the explanation. Okay, these are the knowledge engineering process. It includes totally 6 steps in the knowledge engineering process. Okay, in the knowledge engineering process, first one is task identification. What do you mean by task identification? The task identification is nothing but the first task is to identify the problem that the system needs to solve. Okay, according to the if there are some domain requirements, according to that domain requirements, we include the task, and task can be identified in the task identification. And the next one is acquisition of a knowledge. What do you mean by acquisition of a knowledge? The next step to acquire a knowledge in a subject, this can be done through interviews, workshops, and the surveys. Okay, acquisition of a knowledge is nothing but this is done through interviews. See, we are acquiring the knowledge from so many ways, but in the so many ways, this is the one of the domains that we are getting the knowledge. Okay, not only we are getting the knowledge from books and some through net or ChatGPT or some Copilot, but it also we can get the knowledge through interviews, workshops, and surveys. If you're getting the surveys, we are getting the total knowledge by using the total knowledge, and by using the workshop also we will get the acquisition of the knowledge also we will get in this acquisition of the by using workshops also we are getting the knowledge. And the next one is preparation of the roadmap. What do you mean by preparation of a roadmap? Preparation of a roadmap is nothing but if there is some goal is there, the goal is divided into the manageable chunks, or as one goal is divided into smaller pieces. The smaller pieces we are again work out on this, and we are getting the simple task. To that simple task we are doing by reducing the goal into management chunks using surveys and information. Here subject matter is making judgment. Okay, not only the goal is divided the this simple chunks. Okay, these chunks are again leads to the goal, and very big goal is divided into smaller pieces, and this we are going to work out the smaller pieces or smaller chunks. And the next one is encoding. It's now time to translate the understanding the computer information of various functions, and in certain circumstances an algorithm utilized to develop a particular job. These models can be depending on the variables, just like an export. Whatever the goal is divided into the chunks, again that chunks is we are encoding data into the system through various functions and various algorithms, and we are developing a model for a particular job. These models can be judgments depending upon the variable. It's just like an expert, but they undoubtedly needed to trained and evaluated and encoding the data. Okay, it's nothing but the encoding, whatever we divided into the smaller pieces, that we are encoding into the certain circumstances and algorithms, okay, of a particular job, and finally we are going to evaluate it. And the next one is evaluation and debugging. Once a knowledge-based system is tested, evaluated for accuracy, completion and performance, any faults or errors are found are remedied. Okay, these are the evaluation and the debug. It is tested and evaluated for the we are going to, after performing all this, we are going for the accuracy, and we are going for the completeness of the particular project, and we are checking for the performance or performance of the particular project. And finally, if there are any faults or any errors, again we are finding some remedial actions or remedial solutions for a particular job or a particular process. Okay, whatever that we are developed some project, that project we are going to check for the accuracy and completeness and the performance. If there are any errors are there, again we are performing the remedial action. And the next one, justification and explanation. Finally, the knowledge-based system is validated by providing justification and explanation for the decision and the action. See, finally, whatever the knowledge-based system is validated, okay, whatever the knowledge-based system is validated, we are providing the justification for that. Okay, after providing justification, we are giving some explanation. After that, we are going for decisions and actions. Okay, this is the final justification for the particular process in the knowledge engineering process. Okay, these are the reference slides that we can see in the FOL logic. Last one. Thank you.